Hello, everyone. Welcome to the first edition of Emissions Talks webinar series hosted by Process Ecology. I'm Sophia Alva, your host, and today we will be discussing in depth the recent substantial changes to the federal oil and gas methane regulations in Canada. Throughout this presentation, feel free to submit questions while speakers are presenting, and we will get to these questions at the end of the session. To set the stage, let's delve into the background of these regulatory changes. In 2016, Canada and the US jointly committed to reducing methane emissions from the oil and gas sector by 40 to 45% below 2012 levels by 2025. Fast forward to today, Canada is not only fulfilling but exceeding its commitments. The aim is to reduce methane emissions by 75% below 2012 levels by 2030. These regulations will come into effect on January 1st, 2027 for new facilities, with existing facilities required to comply by 2030. This ambitious initiative builds on the 2018 regulations and aligns with global efforts, including the Global Methane Pledge endorsed at COP26. Today, we're here to explore these changes and shed light on what they mean for the industry today. But before we dive in, let's introduce our speakers. Today, we have experts of Process Ecology, Samine Hajipour, and James Hollaboff. Sam is our emissions manager and process research engineer and has a strong background in chemical engineering and a decade in emissions management. She oversees tier program applications for 20 companies and specializes in regulatory compliance and financial implications. Hi, Sam.
Hello.
James, our managing partner, brings 20 years of experience in emissions data management and compliance best practices. He develops optimal strategies and emphasizes the importance of data management tools to automate processes. Hi, James.
Thanks, Sophia. Hi, everyone.
They will provide valuable insights into the new regulations, their implications, and how Process Ecology can assist in navigating this transition. Before James begins his presentation, I will give a brief introduction of Process Ecology as a company. We'll just bring up the slides. The first slide, please. Process Ecology was founded in 2003 in Calgary, Alberta. We help our clients identify solutions that improve environmental and economic performance of operations. We have extensive experience in process modeling and optimization, emissions management, and software development. We have helped companies in these few industries in upstream, downstream oil and gas, petrochemicals, and biofuels. Slide, please. Our core competencies include emissions estimation and management, process engineering and simulation, and decision support software and tools. Now I'll hand it over to Sam to begin the presentation and to have some comments.
Thank you, Sophia, and hello, everyone. It's a pleasure to be here. Now let's delve into the recent changes in methane regulations to grasp the magnitude of these changes. At COP28, Canada and the US strengthened their commitment to combat climate change by focusing on methane reduction. In Canada, at the government's Faster and Further Canada's methane strategy outlines the roadmap for at least a 75% reduction in oil and gas methane emissions by 2030. In addition, proposed amendments to the federal methane regulations released in November 2022 emphasizes robust inspections and monitoring mechanism. James, could you please elaborate on the key aspects of these changes?
Yeah, certainly. Thank you, Sam. There's quite a bit of ground to cover here. Actually, let's go back to that slide with the outline there. So we're going to cover federal methane proposed regulations. Of course, these were released in draft form in December 2023. I'm sure many of you have reviewed those, may be familiar with those, maybe some have not. So we'll go over the high level, kind of what do those regulations cover. Some of you may be aware that Process Ecology developed a methane mitigation pathway study, which was for all of Canada. We submitted that to ECCC. This served as the basis for the methane mitigation options. And so we'll talk a little bit about that, kind of our role in evaluating costs associated with these methane mitigation options. Next, talk about some of the responses that we've seen to those regulations, including our own, and what we see as the next steps. And then finally, how can Process Ecology help? So yeah, let's go to the next slide. As I mentioned, the federal methane draft was issued December 2023. February 14th was the deadline to submit responses. The timing for the regulation, it's coming in 2027. New facilities after 2027 need to comply with the methane regulations. From 27 to 2030, any facilities with increased production are required to be compliant. And then finally, by 2030, all facilities, new and existing, would be expected to comply with those methane regulations. The overall intent of the regulations is to reduce methane emissions in the oil and gas sector by at least 75% below 2012 levels by 2030. Although we know some would argue perhaps that the onus on the upstream sector as part of the oil and gas sector might be higher than 75%, the way these regulations were written. The total costs associated with the methane mitigation measures was estimated to be $15.4 billion. And this is incremental costs from 2027 to 2040, working out to about an annualized $1.2 billion per year. So next slide. So we're going to talk about a few different aspects of these regulations, starting with routine venting. Certainly one key element that was part of these federal draft regulations was the elimination of essentially all routine venting by either conservation or destruction. It would prohibit operators from intentionally venting hydrocarbon gas into the atmosphere. And that would include all of the equipment that we would be typically familiar with if you've done methane reporting: pneumatic instruments, pumps, compressor seals, glycol dehyes, tanks, Would also include things like well liquid unloading, surface casing vent flows, and some exemptions. This would be associated with health and safety concerns, stable combustion, temporary depressurization. And the estimated compliance costs associated with routine venting would be about 8 billion, which is more than half of the 15 billion cost that I mentioned from the previous slide. So next slide. For flaring and combustion, first, if gas is to be flared, an engineering study would be required concluding that the use of the gas to produce useful heat energy is not feasible, although the definition of feasible was not very clear in my read of the regulation. Secondly, the minimum carbon conversion efficiency associated with flaring would be specified, 98%. And for other types of combustion or catalytic conversion, there's other percentage efficiencies that are required. The other requirements are related to the need to have that flame lit continuously. And so flares would have to operate with a pilot flame, automatic ignition device, and flame failure detection system. So that's some of the high-level items there. The estimated compliance cost there would be in the neighborhood of 3 billion for flaring, combustion, conservation. The next, fugitive surveys. And so before I go into some of the details here, I should clarify type 1 facility is a facility where there's a gas compressor, produced liquid storage tank, or a flare or a gas liquid separator installed. So as you would expect, the type 1 facilities, which would require more fugitive surveys, would be facilities such as gas plants, batteries, oil and gas batteries, compressor stations, and so on, but could actually include quite a number of wells that simply have a gas liquid separator installed. And so for those type 1 facilities, quarterly surveys, plus an annual independent inspection, as well as multiple screenings per year would be required. And then the type 2 facilities, which is everything else, would require a single comprehensive survey plus annual inspection independently done by a third party, as well as multiple screenings per year. Another key addition was the requirement to do fugitive surveys at non-producing wells, 1 survey per year, which is actually a pretty significant addition given that there's in excess of 300,000 non-producing wells in Alberta alone. There are some requirements around mitigating those emissions within a prescribed time frame. So for the largest leaks, greater than 100 kilograms per hour, those would need to be mitigated within 24 hours. And depending on the size, anywhere between 24 hours and 90 days to mitigate emissions. Although there is some allowance for difficult to mitigate leaks with allowance to do it during a shutdown, but that shutdown would be required at least annually in order to deal with those, regardless of the size of the leak. And then lastly, the compliance costs associated with the additional fugitive requirements would be about 4 billion over that period of 2027 to 2040. So yeah, and the last thing I want to point out was just the ability to have a performance-based approach as alternative to fugitive surveys. This is not the same as the alt-FEMP approach that we're used to here in Alberta, where you might have a drone-based or truck-based type of fugitive survey approach. This is specifically continuous monitoring devices at facilities, so fixed devices. 90%, or these devices would have a 90% probability of detecting hydrocarbon gas emissions with a flow rate of greater than 1 kilogram per hour, which is actually a pretty stringent requirement on those devices. For a type 1 facility, as I defined earlier, those would be required to have readings every 15 minutes. For a type 2 facility, once every 12 hours. And the leak mitigation timelines would be similar for the continuous monitoring systems as the fugitive surveys. An additional component of this is that an event analysis would be required for leaks greater than 10 kilograms per hour as part of the mitigation. So just an understanding of the root cause for that fugitive survey, or sorry, for that leak. So yeah, to the next section, our analysis. So I mentioned earlier that we had developed a study to evaluate the various mitigation options and costs associated with them. So really there's three components to this. One is developing the inventory, second, determining the mitigation options and the costs associated with them, and then third, the analysis, development of the MAC curve and the pathway for reduction. So, you know, of course, ECCC used quite a number of different sources. This was one of the sources that was used to kind of bring forward those regulations. So I wanted to give some background on this study. So first of all, the inventory development. Of course, we don't have detailed information of equipment emissions for every company. So our starting point is that public data, Petronix data from 2021, 30,000 plus facilities, as well as a number of other sources which provide input such as from the pool data or PetroNinja into compositional analyses throughout Western Canada. Also, things like a pipeline shapefile allowed us to look at different mitigation options, such as tying into a pipeline and being able to determine the closest distance to a pipeline and the associated pressure at that location, so that we're able to cost out, you know, different conservation mitigation options. So the next step, doing an auto configuration, which is, I guess, to make a long story short, just based on the type of facility, whether it was a plant or battery, compressor station, well, and the location of that facility or well, various rules would be applied to come up with an equipment and emissions profile. You know, we're talking about kind of developing a profile of very specific equipment and emission sources so that the mitigation options associated with that equipment could then be determined. And at the end, we determined, I guess, no surprise here, that most of those methane emissions, of course, were in Alberta. You can see the different breakdown of those emissions by province and by facility type. And also noting that, you know, a lot of those emissions came from, of course, pneumatics, fugitives, vented methane. Other areas would be things like uncombusted methane in flares or combustion. So next slide. So in our analysis, we looked at a variety of mitigation options, developed costing associated with that. I'm not going to go into the details of the costing. Of course, we don't have the time to go through that, but I should mention this is a public report. This is a study that you can download from our website. So if you're interested in further details regarding any of the mitigation options and the costing and the analysis that was done, you can certainly access that. So we covered everything from equipment leaks, fugitive surveys, LDAR, gas recovery and conservation, things like VRU, on-site power generation, tying into gathering systems, virtual pipeline, which is compression of gas and trucking it out. For the compressors and engines, the key source there, or the key mitigation option, was the seal vent capture. Glycol dehydrators, conservation and destruction options. For methane destruction, we looked at flare installation and other combustion methods, vapor combustor and catalytic converter and line heaters. For the pneumatic devices, looking at high bleed to low or no bleed replacement projects, solar electric pump replacements, the installation of instrument air system or compressed nitrogen systems to replace the use of natural gas in powering the pneumatic instrumentation and pumps. So we'll go to the next slide. So kind of all that analysis kind of ultimately leads to kind of determining, you know, where are the best options for mitigation, or not just the best, but, you know, what are the costs associated with each one. So, certainly out of that, you can develop a MAC curve or a marginal abatement cost curve. What this curve shows as you go from left to right are the types of projects that can be employed to mitigate methane emissions. At the far left, we've got projects with a negative marginal abatement cost, meaning, of course, that the revenue associated with recovering fuel gas for those projects would be greater over the lifetime of the project than the costs associated with it. And as you go further to the right, you can see that there's a lot of projects that can be implemented for a reasonable marginal abatement cost. But the further you go to the right, the higher that marginal abatement cost becomes. And obviously, as you kind of reach that last 20–30%, the higher the cost becomes. So I don't think this graph goes all the way to the right, where we've got potentially multiple $1,000 per CO2 equivalent projects, quite uneconomic projects. So certainly what we showed is you can certainly reach 70–80% of the projects at a reasonable level, but kind of once you hit that, the rest of the projects, it becomes much more uneconomic. So next slide, and I think we'll pass it off to Sam to talk about what's next.
Thank you, James. So methane regulations, what's next? So as James mentioned, the federal government accepted feedback on the draft regulations by February 14. So the final regulations are expected to be published in late 2024. And it's also expected to have provincial equivalency agreements. The requirements related to managing fugitive emissions would start for all facilities in 2027. In addition, new facilities and facilities with increasing gas productions compared to the previous year would phase into eliminating venting and limit flaring starting 2027. And all facilities in the oil and gas sector would be subject to the new requirements in 2030. Now I will go through the feedback submitted by Alberta government and PTAC based on their published reports and Process Ecology's feedback and recommendations. So for Alberta government, so we are going through that feedback one by one. Only we put the bullet points based on the published reports. So they think that it's unfair and oil and gas is being targeted. However, methane emissions come from multiple sectors like waste and agriculture. The new changes drive to 85% methane reduction in Alberta, which exceeds the proposed 75% reduction target. It underestimates the cost in Alberta, $9.4 billion estimated by Alberta versus the $8.2 billion estimated by the federal. Overly aggressive and targets are unachievable and impacting production. Targeting low probability and low impact issues, such as inclusion of inactive wells, increased fugitive emissions detections requirements. Phasing regulatory requirements will constrain growth because the facilities with increasing gas production from the previous year will be subject to the regulations on venting, flaring as early as 2027. And they think that's like a punishment for the increasing production rather than to be encouraging. The proposed emissions thresholds of 1 kilogram per hour for continuous monitoring systems is too low, and details of the basis of the performance-based standard nor the technological feasibility are provided. The proposed fugitive detection thresholds, which is 90% probability of detection for 1 kilogram per hour, are not based on widely available technologies. And the last one proposed a third-party screening for fugitive emissions is unnecessary and costly. We also reviewed the feedback from the CAB and we summarized that. Please, next, yeah, thank you. For the cap, similar to the government, so they think that it's not a workable path to 75% by 2030. 100% elimination of venting is infeasible. Many releases with no commercial opportunities for mitigation. Inconsistency regarding flaring. Equipment not available to support compliance with some of the proposed requirements. Extremely high costs for some reductions. Need to better distinguish higher risk facilities from low risk wells. That's related to the inclusion of the non-producing inactive wells. Conventional upstream oil and gas industry can reduce its own methane emission by 70%, but they are not responsible for reducing total sector emissions by 75%. Completing annual comprehensive leak inspections at all non-producing wells represents an enormous, if not impossible, undertaking. And they also challenged some assumptions from Process Ecology report that was referenced or cited by the ECCC. Process Ecology also submitted the responses, feedbacks, and recommendations, so we will go through that as well. Many very small sources of the emissions in the upstream oil and gas industry will be very expensive, extremely high marginal abatement cost to destroy and conserve, similar to the chart that James showed during the presentation. Significant logistics and resourcing challenges to implement too many projects in next 6 years. Need to consider alternative fugitive survey methodologies. Need clarification on methane slip inclusion in the methane inventory. Clarification on proposed fugitive detection thresholds. That's related to the 90% probability for detecting 1 kilogram per hour flow rate. It's not clear if it's device specific or it's based on a vendor review and claim or it's a facility specific. Clarifications also needs to be provided regarding event analysis in continuous monitoring system and regarding engineering study for flaring. There were several responses submitted and some of them are published and available for your review. While the government is reviewing the responses and finalizing the regulation, we as a Process Ecology can advise you on how to ensure compliance with the proposed regulations and update you on the upcoming methane regulatory changes. Thank you for your attention. I hope you found the information valuable. Now I'd like to pass it to Sophia for the next session.
Thanks, James and Sam, for your presentation. Yeah, just wanted to also remind everyone to submit your questions in the Q&A box there. We'll be answering questions from the audience. Yeah, I'll just start asking some of the key questions that stood out from that presentation. First off, James, how do these changes impact producers today?
Yeah, it's a good question. Certainly, as we discussed, the methane regulations don't kick in until 2027. Obviously, these are draft federal regulations. I think the final form of these remains to be seen. And of course, as we saw from several years ago when we went through the initial methane regulations, it went through a period where the different provinces went through an equivalency process, developed regulations which were essentially equivalent to the federal requirements. So obviously there's some, I guess, negotiation that needs to take place before we get the final form of these regulations. As for kind of how that impacts operators today, I think they need to be thinking about it. I mean, we know that kind of the ultimate goal is 75% reduction by 2030. Obviously, the final form is unsure, but it's clear that they'll have to continue with the mitigation projects. And certainly by doing the kind of analysis that we did, a marginal abatement cost curve, they can identify those, the most economic projects first, and really look into those, and I think start planning, because I think it comes very quickly, and I think companies really need to start thinking about the capital and operation expenditures associated with those mitigation changes.
Thanks. So producers should definitely be thinking about strategies and planning this year in 2024. Next up, Sam. Can you please elaborate on how Process Ecology can support producers to ensure compliance?
Okay, that's a good question. First of all, we stay on top of the methane regulations update, and we'll update the producers with the most recent changes in the regulations. We can also advise oil and gas producers on how to ensure compliance and support them on their decision-making on mitigations project, using our expertise and tools such as Emissions Advisor for emissions quantifications and reporting, our team tool, which is a techno-economic analysis model for developing optimal mitigation strategies, and RTGHG tool, which is a real-time GHG emissions tracker that combines plant sensor data or discrete measurements and advanced process models to track and manage emissions from a facility. While the federal government is finalizing the regulations, we can also assist producers in assessing their potential impact of the proposed regulatory changes on their operations and also business model.
Thanks, Sam. Process Ecology has lots of experience dealing with changing regulations throughout the years, so we are well equipped. James, the performance-based approach includes continuous monitoring. How can that become a reality, and would you recommend to opt in?
Yeah, it's an interesting question. I think it's great that this alternative performance option is provided as part of the regulations. I think it's a little bit unclear. I think many elements of it, to me, I think how that would work. So I think, before I say yay or nay based on the regulations, I think I'd have to understand a little bit more about some of the specifics around the requirements for that continuous monitoring system. Having said that, I think companies today are seeing a need for that for a variety of reasons, whether it's the need to be more on top of existing emissions, certainly around ESG reporting, for example. Quarterly reporting, especially for larger facilities, understanding that they are going to be in compliance, or I guess the emissions are going in the right direction as expected. So it provides a way to kind of have quicker feedback into what's actually happening at facilities. I think another benefit would be the ability to be on top of those changes, emission sources, and maybe be able to respond quicker and understand the root causes behind some of those, especially if it's coupled with maybe a system which ties into the SCADA system, or the historian for that facility. So I think we can get at some of the root causes there, looking at temperature, pressure, flow data, analyzing that and being able to get at the root cause. And this is something that we do here at Process Ecology through our RTGHG solution. And maybe one thing I'll mention, certainly with things like OGMP and Veritas and some of these other programs in place, companies are starting to put in these continuous monitoring systems. So I think there's a lot of reasons for it. I think the regulations could be one of them, and I think it really depends on the objective for that company.
Thanks, James. Yeah, with so many upcoming technologies, this may become more accessible for companies in the future, but it does take time. Sam, The main objective of these regulations is to drop methane emissions by 75% from 2012 levels. Do you think that these new measures will help us achieve that goal by 2030?
On paper, yes. As per Alberta government responses to the proposed changes, new requirements drives to 85% methane reduction in Alberta. But do we have that enough resources and budget to manage the large number of projects in the next 6 years? This also depends on the feasibility of the technological applications and geography and weather in different areas, specifically in Alberta, that may impact the requirements for fugitive detection. James, do you have anything else to add?
No, I think that's good, Sam. Actually, maybe it would be an appropriate time to maybe go to some of the audience Q&A. Sophia, if you agree.
Yep, I agree. We've got some questions coming in.
Yeah, maybe I'll tackle one of the first one that came in. I'll keep it brief. Has the province of Alberta adopted the federal methane regulations, or what's the likelihood that they may oppose or not enforce them? And of course, I think during the presentation, we did partially address that. Obviously, there was the Alberta government response. Of course, we fully expected the Alberta government to object to many elements of the regulations. So I think we have to go through this period of, ultimately what I would expect, equivalency to ultimately get to the final regulations. But of course, the current government, we're not sure how they ultimately might respond about, complete and outright rejection of them. But I think we'll ultimately get to the point of equivalency and having a set of methane regulations that we can agree on.
Thanks, James. Sam, is there a question there that?
Yeah, there is something about that 85% reduction. If this is the correct interpretation, there is a need to reduce methane emissions by 85% in Alberta to meet ultimate federal goals by 75%. And then what's the source of this information? Is it the federal? The 85% in Alberta, this is from the Alberta government's responses report submitted to the federal. This is available online. We can provide the link of that report to you. And yeah, so they think the Alberta government assessment shows that the requirements leads to 85% emissions in Alberta, not 75%. That's exceed the target. For example, eliminating all the venting or limit on the flaring, all the fugitive detections, altogether, all these requirements leads to 85% instead of 75% in Alberta.
Yeah, I'll take the next question. It's an interesting one. It says OGMP data suggests that fugitives are less of a percentage of the emissions pie than previously thought. Have there been any conversations with ECCC that you know of in framing the regulations more around engine emissions reduction and less on LDAR? And yeah, it's interesting. I partially attended the EU-Canada talks this morning. I had to leave because I had to prepare for this session. But I saw the same thing, and a couple of the things that came out of the presentation, including one from Shell, was while kind of before they did the measurements, they had thought that most of their emissions came from things like pneumatics and fugitives, but they found that slip associated with, or I should say methane slip associated with combustion and flaring was actually the major component of it. So I think it's an important discussion to have. It's certainly something that we considered as part of our report that we submitted to ECCC. As far as the specific conversations, yeah, I'm not sure about all of those. I think it's a discussion that we need to have. My personal opinion is I think in methane reporting, we should be considering this source, maybe initially, at least as a factor, because I think in many cases, for many companies and facilities, it could actually be one of the major sources. And of course, we want to direct dollars at the major mitigation opportunities.
Okay, I'll take another one. Okay, how methane is used as a fuel? So that's a good question. The methane related to the fuel or combusted, that's called slip. So then, it's not clear how it's need to be included in the methane regulations, but for now, I think it's not included. It's only the methane from the venting sources, pneumatic, glycol. The sources that James mentioned in the slides. It's not the methane asleep. The uncombusted methane from the combustion sources is called methane asleep, and the regulation is not clear on that. So this is one. That was one of the points that we added in our response and asked for the clarifications on that.
Sophia, do we have time for a couple more questions?
Yeah, we have about 5 minutes left. We will get through as many of the questions as we can. We probably only have time for a couple more. But if we don't get to your questions during this session, we'll send a follow-up email with a response. So please submit your questions. If you have any, we will respond to them after the session as well. So yeah, a couple more.
Okay, I think there's a couple similar questions here. So I'll choose one here. Is the intention of Process Ecology to update the MAC curve as new technologies become commercialized and existing ones become more cost effective? There was another similar question regarding improving the modeling approach. And of course, as Sam mentioned, in the CAP feedback, they had some comments about specific assumptions that were made. And certainly, as we get better data, we certainly look to improve that. We work with organizations such as the Methane Emissions Leadership Alliance, which, there's many companies, technology providers as part of that. And, we also work with specific technology providers, and we're always looking for ways to better improve or better understand the technologies out there and improve our costing, our capital cost and operating cost estimates for those technologies. So I would say yes, we look for continuous improvements. The one thing I will say is, I think the costs, that 15 billion number, I know CAP had indicated maybe that was a bit low. When we looked at the provincial response, they had mentioned for Alberta, they thought the 8 billion or so for the Alberta was low. They thought it should be about 9 billion, which to me was actually pretty close. Maybe that's an indication that the overall costs were certainly close and certainly not an order of magnitude off. So I think I guess to kind of summarize, we do look to improving those models and hopefully updating those results.
Okay, time for one more question, Sam.
Okay, I will respond to this. Cannot publish. Okay, it's published. New regulation appears to be very costly to implement. $15 billion. When do you think methane venting will be a part of the aggregate compliance calculations? So I think that question is about the tier aggregate compliance calculations, if I'm right. For now, maybe 2-3 years, in the following 2-3 years, the tier aggregate stays the same, including fuel and flaring. But in the next provincial equivalency agreement with the federal fuel charge, I think they may consider venting. That's something the tier, the Alberta government was talking about that in one of their webinars. It may come, but for 2-3 years compliance reporting, it stays the same, only fuel and flare.
Thanks, Sam. Before we conclude, we invite you to join us for our next webinar in June. So stay tuned for more engaging discussions on industry trends and innovations. Thank you, everybody, for joining. And a big thank you to Sam and James for sharing your expertise with us today. Your insights are valuable as we navigate these regulatory changes.
Thank you so much.
Yep, thank you.
Thank you. Have a nice day, everybody. Thanks for joining.